In this video, I will show you how to solve quadratic equations by factorizing. Now, a quadratic equation is the general form ax squared plus bx plus c is equal to 0. We are going to focus on those equations where the a value is actually 1. Now, if you look at that general format or standard format of the quadratic equation, you discover that the first term on the left hand side has got x with an exponent 2. The middle term has got x to exponent 1. And the last term, has got no x, or you can actually say it's got x to the power of 0. That is the general format of the quadratic equation. If you're going to solve quadratic equations by factorizing, you need to ensure that all your equations are in that format first. Once the equation is in that format, then we can easily factorize it. Let's start by multiplying out two binomials. We know that the product of two binomials will be a quadratic trinomial, ax squared plus bx plus c. The first thing we need to do is to multiply the x and the x. X times x will give us, x squared. Now, to generate the middle term, we're going to do a small shorthand. We're just going to write plus x and open a bracket, leave it like that for now. And then we know that the last term in a quadratic trinomial is always the constant term. So 4 times minus 7 is what? Negative 28. What terms do I put in the bracket? Well, I'll take the 4 and the negative 7 and put them inside the bracket. So the 4 and the negative 7 goes in there. 4 minus 7 is negative 3, right? Then negative 3 times x, negative 3x. So the quadratic trinomial that I now have is going to be x squared minus 3x minus 28. Now I know how to multiply two binomials to get a trinomial. To factorize a quadratic trinomial, I'll do the reverse. Suppose I have x squared minus 9x minus 10. I want to factorize this. Okay? I'm going to need to take it into the format that I did in the previous multiplication. I'll write x squared plus x, open bracket, minus 10. Two factors that go into the bracket, two numbers that multiplied when they give you 10, subtract them, they give you 9. 1 and 10. So 1 times 10 is 10. 1 minus 10 is negative 9. Because the middle term is negative, so it means the negative factor is the bigger factor of these two. So it's minus 10. Now all I need to do is now to write two brackets, x with the positive 1 and x with a negative 10. I now take those two numbers inside the bracket. Once I can factorize a quadratic trinomial like this, it means I am now ready to solve a quadratic equation using the technique of factorizing. If I have AB equal to 0, it means either one of those factors is 0. Either A is equal to 0 or the other factor, which is B, is equal to 0. Now the factors in this case, they're going to be binomials. For example, x plus 5 times x minus 3 equals 0. X plus 5 is a factor. X minus 3 is a factor. So it means either x plus 5 is equal to 0 or the other factor, x minus 3, is equal to 0. Now I've got two simple linear equations that I can solve easily. X equals negative 5 or x is going to equal to a positive 3. That is the basic introduction as to how we're going to be solving quadratic equations by using that factor approach, that if two factors are multiplying each other and their product is equal to 0, it means one of the factors is 0, and then we can solve those equations. Practice questions. Number 1, we've got x squared minus x minus 20 equal to 0. Let's factorize. X squared plus x open brackets minus 20 is equal to 0. The equation was already in standard form, so we can jump on straight to factorize. Now we need to list all the factors of 20 that give us a sum or difference of 1. The coefficient of negative x is actually negative 1. We can have 20 and 1. The difference will be 19. Remember, it could be a negative 19, it could be a positive 19. The sum will be 20 plus 1, which will be 21. Again, it could be negative 21, it could be positive 21. None of these factors, none of the sum or the difference of these two numbers give us the one that we want. So we need to try another set. Let's try 10 and 2. The difference is 8 and the sum is 12. So these two factors again will not work. We need to try another set of factors. Okay, let's try 5 and 4. Looks like 5 and 4 can work, because 5 minus 4 is 1. 5 plus 4 is 9. So it means we've identified the factors that can actually work if we place them in the bracket, and they'll give us the original trinomial that we had. So we're going to place in the 5 and the 4. Here, since the middle term has got a negative coefficient, it means the bigger factor must be negative. In this case, the bigger factor is the 5. So it's going to be negative 5, and then it's going to be plus 4. So now I know that in one of the brackets I'm going to have x and x, negative 5 in one bracket, and the positive 4 in the other bracket. And all of that is equal to 0. Now, two binomials multiplying each other equal to 0 means one of the binomials is equal to 0, x minus 5 is equal to 0, or it can also be the other one, x plus 4 being equal to 0. Now I've got two system of linear equations that I can easily solve. Move the negative 5 across, becomes a positive 5, x equals 5. Move the positive across, becomes a negative 4, x equals negative 4. Number 2, we've got x minus 1 multiplying x plus 8 equal to negative 20. In this case, this equation is not in standard quadratic format. Standard quadratic format is the ax squared plus bx plus c equal to 0. So we need to convert this equation into quadratic format. I think the first step we can do is to multiply the two binomials on the left hand side, bring the negative 20 across to the left hand side. That means everything on the left hand side is now equal to 0. Let's do that. So we're going to have x times x, x squared, plus x open bracket minus 8, because it's minus 1 plus 8, minus 1 times 8 rather, minus 1 times 8 will give us minus 8. All of that is equal to minus 20. The middle term, how we're going to generate it, remember what we said? Take the negative 1 and the positive 8. Place them inside the bracket. Now let's add these two terms. Minus 1 plus 8 is a positive 7. So the quadratic trinomial on the left hand side is going to be what? It's going to be x squared plus 7x minus 8. All of that being equal to negative 20. Here what we can now do is add 20 to both sides so that we can get rid of the negative 20 on the right hand side. X squared plus 7x minus 8 plus 20 will be the positive 12. All of that is now equal to 0. Now let's factorize here. X squared plus x open brackets plus 12 equal to 0. At this stage, you don't have to list the factors if you can also process it mentally. That is the ideal. Ideally, I would want you to actually process this stage mentally and say two factors of 12 that give me a sum or difference of 7. Then you try to figure it out mentally. But still, we're introducing this idea. Let's list them up. 12 equals 12 times 1. What will be the difference of these factors? And what will be the sum of these factors? Okay, so the difference between 12 and 1 is 11. The sum is 13. So these two factors cannot work because the sum or the difference is not 7. We need to try another set of factors. Okay, factors of 12. We've tried 12 and 1. We could try 6 and 2. Okay, the sum of 6 and 2 is 8, and the difference of 6 and 2 is 4. Okay, remember this could either be negative or positive in terms of the sum of the difference. Okay, but again, it's not working out. We're looking for 7. We want the sum or the difference of these factors to be equal to 7. Let's try 4 and 3. Well, we could try 4 and 3 because 4 minus 3 is 1, but 4 plus 3 is 7. So 4 and 3 look like they can work. Okay, 4 plus 3 gives me the 7. So let's write the 4 and the 3. Okay, our middle term is a positive 7. So it's going to be 4 plus 3. So which means our brackets are going to be x plus 4 and x plus 3. All of that equal to 0. So what are we going to do now to finish this? Well, either one of our factors must be 0. So either x plus 4 is 0 or x plus 3 equals 0. Solve the simple linear equations that we've got now. X equals negative 4 or x equals negative 3. Number 3. X squared plus px minus 2p squared equal to 0. Does this look like a quadratic equation? Well, we know that the standard form for quadratic equation is ax squared plus bx plus c is equal to 0. If we think about it, actually that expression on the left hand side, they are decreasing powers of x. The first term is x squared, second term is x to the power 1, third term is no x, or maybe you can even say x to the power of 0. So this is a quadratic equation. It fits in that ax squared plus bx plus c is equal to 0. P is the coefficient of the middle term, minus 2p squared is the last term. So let's factorize this. X squared plus x open brackets minus 2p squared is equal to 0. Now let's generate the terms that go inside the bracket. We could say 2p squared, the last term, is found by multiplying 2 and p squared. In that case, what will be the sum of 2 and p squared? 2 plus p squared. The difference, 2 minus p squared. Okay. Again, this sum of the difference of these two terms is not giving me p. So these factors will not work. I need to think of other factors of 2p squared. 2p squared. What other factors can I have? I can have 2p and p. 2p times p is 2p squared. What will be the sum of 2p and p? Is 3p. What will be the difference of 2p and p? It's p. So I found factors that can work because the difference there is p and the product is 2p squared. So I'm going to write 2p and p in the bracket. Okay, I can clearly see that the middle term is a positive, so it means the smaller of the terms must be the negative, so it's going to be negative p. Alright, now I can get the terms that go into the bracket. X and the positive 2p, x and the negative p. All of that is now equal to 0. Again, I've got two factors multiplying each other to give me 0. One of the factors must be 0. x plus 2p is equal to 0, or x minus p is equal to 0. I can actually solve this equation now in terms of p. Take the 2p to the right hand side, becomes negative 2p, x equals negative 2p. Take the negative p to the right, becomes a positive p, x equals p. Okay, so initially it didn't look like a quadratic equation, but it is a quadratic equation, and we actually managed to factorize this. Question number 4. We're given a rectangle with the length x plus 5 and the breadth x plus 2. In the diagram alongside, the rectangle has length x plus 5 and breadth x plus 2. If the area of the rectangle is 70 square units, determine the length and breadth of the rectangle. Okay, so we're told that the area is 70. How do you get area of a rectangle? Oh, area is length times breadth. So if I multiply the length and the breadth, that should be equal to 70. So x plus 5 times x plus 2, which is the length and the breadth, should be equal to 70. So I'm multiplying two binomials and they're equal to 70. I can convert this into a quadratic equation by bringing the 70 to the left hand side after I simplify the left hand side. Sounds like a plan. So let's multiply the two binomials on the left hand side. Okay. So how are we going to multiply? Remember, there's a way in which you can multiply them that allows you to be able to see the factors. So x squared, add the 5 and the 2, you get 7. So the middle term is 7x. 5 and times 2, the last term will give you 10. All of that is equal to 70. Next step, remove 70 from both sides. You remain with x squared plus 7x minus 60 is equal to 0. Now let's factorize. X squared plus x, open that bracket, minus 60 is equal to 0. We want to think of factors of 60 that give us a difference of 7. 1 and 60, no. 2 and 30, 2 and 30, no. 3 and 20, no. 4 and 15, 4 and 15 give us 11, no. But 12 and 5, 12 and 5 actually give us 60, but 12 minus 5 is 7. So the two factors are 12 and negative 5. So which means now our two binomials that we can have is x plus 12, x minus 5, and all of that is equal to 0. One of the factors must be equal to 0. So x plus 12 equals to 0, or x minus 5 is equal to 0. So x must be equal to negative 12, or x must be equal to a positive 5. But we're dealing with length here, length, dimensions. So we have to reject the negative value. So we have to reject that x equals negative 12 because we end up with negative length. And then we say our acceptable answer is going to be x equals 5. So now we can get the length of this rectangle. It's going to be 5 plus 5, 10 units. And the breadth of this rectangle is going to be 5 plus 2, 7 units. (5.1) Solve for x. X squared minus 4x minus 5 equal to 0. 5.2 Hence solve the equation x squared plus 1 in bracket squared minus 4 open bracket x squared plus 1 close bracket minus 5 equal to 0. Okay, let's start with 5.1. X squared minus 4x minus 5 equal to 0. At this stage, guys, you can immediately open two brackets and factorize. But let's just continue doing the long method again so that you drill it in. We're looking for two factors of 5.
that gives us a difference or a sum of 4. Those two factors are 5 and 1. How do we use these two factors to get negative 4? Make the big factor negative, make the small factor positive. Hence you have negative 5 and positive 1. So which means in the two brackets I'll have x minus 5 and x plus 1 equal to 0. This means now either x minus 5 is equal to 0 or x plus 1 is equal to 0. X equals 5 or x equals negative 1. Moving on to 5.2. When we look at that equation, we can see that there's a term that is repeating itself. X squared plus 1. What if we replace that x squared plus 1 with a simpler term, like for example k? We will turn that whole equation into a quadratic equation. So let's let k equal to x squared plus 1. We substitute x squared plus 1 with k. This will form a quadratic equation. We'll now form the quadratic equation that says k squared minus 4k minus 5 is equal to 0. Notice how this equation is similar to x squared minus 4x minus 5 equal to 0, which we've already solved. So we now know that k equals 5 or k equals negative 1, since x was 5 or x was also negative 1. So this now means that x plus 1 is equal to 5 or x plus 1 is equal to negative 1. We can solve these two equations by moving the 1 across the equal sign, and then it becomes a negative 1. So we'll have x squared equals 4 or x squared equals minus 2. Solving x squared equals minus 2, we won't get an answer there, because we'll end up with x equals the square root of negative 2. We can now solve the x squared equals 4. What is the square root of 4? It's a positive 2 or negative 2. So x equals 2 or x equals minus 2. Let's move on to the last question, question 6. X squared equals 5x. I could easily divide both sides by x. I remain with x equals 5. But then the highest exponent on the variable is 2. So which means this is a quadratic equation. I need to get 2 answers at least. How would I make this into a quadratic equation? Well, if I move the 5x to the left hand side of the equation, I'll now equate everything to 0. X squared minus 5x is equal to 0. This is a quadratic equation. The only thing different is that in this case the constant term or the c term is actually 0. So we've got a binomial on the left hand side. Okay, let's factorize that binomial. What is the highest common factor there? X. So we can factor out x, and what will remain inside the bracket is x minus 5. So let's do that. So let's factorize and let's get the highest common factor. Okay, so x and x minus 5 is equal to 0. This now means we've got our two factors on the left hand side multiplying each other to give us 0. X is one of them, x minus 5 is the other one. So this now means that either x equals 0 or x minus 5 is equal to 0. We can now solve the simple linear equation, the x minus 5 equal to 0, and therefore we have solved this equation, x equals 0 or x equals 5. So there you go guys, that's how you can solve quadratic equations with the coefficient of x squared being 1. We'll see you next time when we discuss other quadratic equations that have got a coefficient of x squared not 1. Thanks for watching. Don't forget to hit the subscribe button. See you guys next time.